Okay, we're back talking about section 2.3, the function notation, the function section. So where we left off, we had learned about using the function notation f of x or g of x, or sometimes they use h of x. It can be any letter. So the letter names it function f, function g, so we know when we're talking which one we're talking about. And then the x means that's the input variable using the equation. So I'd like you to look at these 5 problems and try working these problems with these 2 functions given. So please pause the video to do so. But I'm going to go ahead and start working. So to do f of 3 means pick function f, plug in a 3 for the x. So that'd be 3 times 3 minus 5, or 9 minus 5, which is 4. 4 is the answer there. If we were graphing this, that would mean the point x is 3, y is 4 is given. G of 2 means go over here to function g, plug in x is 2. So that would be 5 times 2 plus 7. 5 times 2 is 10, plus 7, 17. Now we get into a little more algebra on this one. G of a plus 4. So go to function g, plug in a plus 4 for the x. So a little more algebra there. We should distribute the 5 and get 5a plus 20. Then plus 7, and here we won't just get a nice point. It'll be an algebraic expression. Okay, on number 4, we're going to do an addition of functions. We're going to add function f plus g at 7. Now you can do this a couple of ways. One way, you could go ahead and add the functions, 3x minus 5 plus this function. Combine like terms and get the added function, and if there was only an x there, that's all we would do. But since there's a number, we're going to plug a number in for x and get 56 plus 2, or 58. Now I know you'd get the same answer if you did it individually. We could have done f of 7 plus g of 7 and worked it individually and avoided the algebra since we have a number here. So f of 7 would have meant 21 minus 5. And then g of 7 would have been 35 plus 7. And then when we add those together, look at that, 58. Same answer, just a different method. So whichever way is easier. But again, we're adding functions, plugging in a number, or doing them individually and then adding them together. On number 5, we don't have the luxury of a number here. It just wants us to do the algebra, function f minus function g at x. So function f, subtract function g. So since we're subtracting, it will distribute the subtract. It would look like that. So you do need to either remember to distribute that or just go ahead and write it with both of these with a negative applied. Then combining your like terms, that is your final answer. There's not a number to plug in on this one. All right, moving along. Number 6. Number 6 introduces a new little notation with a little open circle. It's called a composite function. It means a function within a function. Some books write it like this instead. That means function g inside of function f. So a function put inside of a function. The second one plugged into the first one. So function g plugged in to the x or x values if there's more than one. Instead of that x, we write 5x plus 7 minus 5. And then simplify. 15x plus 21, which is 15x plus 16. And that would be your answer for f of g of x. We can also do that in reverse. It's not on your paper here, but let me just show you. If we do g of f of x, we'll call it 6.5. That means put function f into function g. So we'll do it the other direction. So we want to plug this function f into the x value that way. So we'll have 5 instead of x, we write 3x minus 5. And then plus 7. Distribute. And simplify if there is anything that you can simplify. And then that would be our answer to that. So fog and golf there. Number 7 instead of the little open circle, which can easily get confused with this next one, it's just multiplication. FG means F times, a little understood times sign there, of X, so no number to plug in. So we want to multiply function F, all of it, so put it in parentheses, times all of function G. And that is the FOIL method. We have to FOIL that. First, outer, outer, inner, inner, and then last times last. And then combine any like terms. And that would be your answer there. Now again, if there's a number in this parenthesis, then we can follow up with plugging in a number for the x's and work it out. But if it's only F times G of X, it means leave it in terms of X alone. All right, let me have you do one more of these with the new functions to practice this. So we've got new functions. F of X is negative 3x plus 1. G of X is negative x squared plus 4. So I would like you to, let's do a couple of these, maybe not all of it. Find F of 3, G of 2, G of a plus 4. So please do pause the video and try a couple of these. All right, so for the first one, function F, plugging in a 3 there will be negative 3 times 3 plus 1. Negative 9 and 1, that's negative 8. G of 2 means plugging in 2 there. Now this negative is not in a parenthesis, so the negative is outside of the x. We're plugging in 2 just for the x. So it would look like that if we showed all of the detail. So the 2 is squared, but the negative is like a negative 1 weighting. So that's 4 minus 4 and plus 4. That's just a big 0 there. Then lastly, last one we have here, plug in a plus 4 for function G. So that's this one. Too bad it's not over here, right? This one's a little tougher. We've got the negative to kind of mess with us. Remember, that's just a negative 1 though. Then plugging in for this x is a plus 4. It says to square it and then to add 4. So we got a little algebra to work on there. What I would do first is this squaring and then times by negative 1, distribute that out. So how do we square a plus 4? That means a plus 4 times a plus 4. That's the FOIL method. So we would do first, which is a squared. Outer is 4a. Inner is also 4a. And last times last is 16. For a total of a squared, 8a plus 16. Again, notice when you square a binomial, you get the square of the first and the square of the last, as you might expect. But you also get the middle parts. The middle parts double from the inner, and outer, so you wind up getting 8a there. Then distributing the negative 1 and adding the 4. So times through by the negative sign to change all the signs there. Combine your like terms. And that is your final answer for that one. All right, the next part of your handout, we're going to go back to talking about domain and range a little bit more. So on the next page, we've got a few functions. Back to that again. It's a really important concept with graphing. You'll be asked about the domain and range of any graph. That's a question you may get asked. So we're going to talk about how we can graph these, determine if they're a function, and also find their domain. So again, feel free to pause the video, use your graphing calculator, and think about the domain and range, and also whether these are functions. Well, I guess you can tell they are functions. They're all labeled, like with the function notation. So that kind of gives that away. So yes, all of these are functions. And when graph, you should be able to tell that about them. The first one is a parabola. Actually, to figure out what this one looks like, I would use my graphing calculator. I would look for where the vertex was on that one. and then see how far, actually, my graphing calculator is on my phone, which I'm filming now, so I'm going to have to do this another style, which we're going to learn later, so I'll go ahead and mention this here. But what I would have you do with your graphing calculator is plug that in as y equals x squared minus x minus 6. Graph that and see what it looks like, and see if you can figure out what the lowest y point is. Now, the domain of any parabola, it's a parabola. It swings like this, so it opens, the arms open left and right without bound. The domain is anything goes. But what is this lowest point, the y value? What is that point? And I've got caught here without my graphing calculator, and I'm going to have to do a little bit of algebra to figure that out. Now, the way we're going to learn this in the next chapter, so if you just want a heads up for later, the vertex of a parabola, this lowest point, is found at negative b over 2a. You've got a, b, c in your quadratic equation. So you take the opposite of the b value, which will make this positive 1, over 2 times the a value. So that's what that says, negative b over 2a. So that's how far it is over. It's over a half, but how far is it down? So what I have to do to figure that out is I do f of what I just found, 1/2. I plug 1/2 back into the function. So it'd be a half squared minus a half for that x minus 6. So I've really got myself in trouble doing fractions and all of that. So what is that? Let me see. That would be the same thing as being 2/4. So a fourth minus 2/4 is negative a half minus 6. All right, negative 6.5. Oh my goodness, sorry about that. I didn't mean to get us into those tall weeds there. That's for another day. But you might be able just to tell it on your graphing calculator. That is negative 6.5 or negative 6.5. That's a low point for the range, we would say. Now the domain, like I said, is anything goes. Domain is that, but the range has a low point at negative 6.5, and then it's going up to positive infinity. All right, sorry about that mess I made of that one. Okay, the next one, we've seen this guy before. The square root function looks like that, and it's in its simplest form. So you can plug in 0 and get 0. That is its basic form there. So we would say the domain, 0 to infinity. The next one, 1 over x. Now this one may require some thought. We haven't talked about it together that I can remember, but try plugging in some values, or just look at your grapher. If you try plugging in 0, 1 divided by 0 is undefined. And so that is not in the domain. Domain means what can you plug in for x and get an answer, a real answer for y. Well, certainly that didn't work. 0 is not in the domain. Actually, anything else is. I can plug in 1. 1 over 1 is 1. I can plug in 2. 1 over 2 is a half. 3 is a third. A million is 1 millionth. I can plug in negative numbers. 1 over negative 1. You can plug in any negative number. You can plug in fractions. You can plug in negative fractions. Anything else was okay. The only problem with this guy is 0. You cannot have a 0 in the denominator of a fraction. So the way we would write that is the domain is negative infinity up to 0 with a parenthesis, showing that we're not going to touch it or include it. Union, and then we start over on the other side of 0 and go to positive infinity. Now, if you notice on your graph, if you've plotted that, you get these two repelling looking curves like that. So there is a split at 0 in the domain, left to right. It jumps over. There's undefined, so it makes a break in the graph. And then there's also a break this way in the graph for the range. It also cannot achieve an answer of 0. And that's because there's a constant there. The only way for y to equal 0 is if the numerator is 0. 0 divided by anything is 0. Well, there's a constant there. So you can't get an answer of 0 for the range either. But anything else would be achievable there. All right, and I'll have to come back to that idea. So I'm going to go ahead and finish up this video, and then I'll talk to you some more in just a little bit.